Hey, welcome to Ninson's Smart Solutions videos again. In this video, I'm here to show you the secrets to understanding integration using the reverse of the chain rule. Remember, this is skill number 2. In this video, I also get to solve exams questions. Some are very tricky. I'd like you to focus and pay attention. Grab a pen, a piece of paper, and a calculator, and by all means, feel free to pause the video, have a go at the questions, and see if you can solve it. If not, then follow through with me. Thank you for staying tuned. Hey, welcome to our next skill on integration using the reverse of the chain rule. Okay, so remember in our first video, if you haven't watched it, please try and watch it because we spoke about what we mean by standard integration, the way integration should be done basically. Now we're looking at situations where our standard doesn't quite work, and we'll look at some difficult exams questions and how to go about them. Okay, so make sure you grab a pen, a calculator, and by all means, I'll be solving questions. I want to solve 3 questions in this video, and I'll show you the secret in the reverse of the chain rule technique. Make sure to pause the video and have a go and check your answers. And these questions are exam style questions, so by all means, make sure you take it very serious. Okay, the first question I would like us to look at integrating is integrating sine 2x add 1 with respect to x. Okay, now in integrating this, how do we use the reverse of the chain rule? So the reverse of the chain rule says, what do you know to be when we differentiate? So what do you think will be differentiated to give me sine? Okay, so that's where we're thinking about. So I'm thinking if I had y equals cos of 2x plus 1 with respect to x, of course is a function of x, and I differentiate this dy dx sine, because cos minus, I'll get minus sine 2x plus 1, and then times by the differentiation of 2x plus 1, which is just 2. So this therefore gives me my dy dx to be minus 2 sine 2x add 1. If you notice, our answer has the 2 sine 2x add 1, just like the question, but we have a minus 2 there that we don't want. So what that simply suggests is that if we look at this, which we assumed to be our answer, this is our assumption, so we assumed that our answer will be cos 2x plus 1. However, when we differentiated, we got a minus 2 there, and the question doesn't have a minus 2. So we need to find a way to go back to our assumption and then adjust it. Okay, that's what the reverse chain is about. So it says you are assuming that to be the answer. When we check our differentiation, remember differentiation is used because it is the reverse of integration. Okay, so when we differentiated, it wasn't quite it. So we adjust it, so I'll write adjust. That helps me to take note of what is it that I'm adjusting. So I'm adjusting my y equals the cos 2x add 1. Okay, and because I know when I differentiated I'll get a minus 2, which I don't want, therefore I should have minus a half in front of it. What that means is, therefore, when I integrate sine 2x add 1, I am definitely going to have minus a half cos 2x add 1. Don't forget, add c. Why do we add c? This is an indefinite integral. Okay, and that is our answer. So sine 2x add 1 will give me minus half cos 2x add 1 bracket add c. That is the first question. Okay, now let's get the next question on this. The next question is says, given the integral of from 3 to b of 2x minus 6 all squared with respect to x equals 36, it says find the value of b. Okay, so we're going to look at how we can solve this they've given us our answer should be. This is not an indefinite integral, this is definite. So we've got values to substitute in. So first of all, we're going to integrate this question here. Just like we saw in the previous example, here we'll be looking at making an assumption what our answer is. Anytime there is a power and you are going to the reverse of the chain rule, we have to think of the highest value that it could be the next power up. So I'm gonna make an assumption and just say assume that y is 2x minus 6 all to the power 3. Why is it to the power 3? Because I know in the back of my mind that when I differentiate, I will reduce the power by 1. So let's check. By differentiating this, I'll differentiate the whole thing times differentiate what is inside. Okay, so this is important that we understand how to differentiate things like this. So we differentiate the whole thing, 2x minus 6, and then we go square there. We're gonna times it by differentiating 2x minus 3, which is just 2. This will simplify to give me 6 bracket 2x minus 6 squared. Just like we saw in the previous example, over here we've got a 6, but in the question there's no 6 in front of our bracket. Everything else is perfect. So what we're gonna do is go back to our assumption and then try to adjust it. So I'll write there adjust. Okay, it's very important to follow, go to your assumption, so it helps to see where you're going off and you can always monitor. So when I'm adjusting, I don't want the 6 there, so I know to get rid of the 6, my question should have actually been 1/6 of 2x minus 6 to the power 3. So I know I've got that. Now remember, this is definite integration, so I'm not going to add the c, but now I need to substitute values in. So I've got 1/6 there. So the first thing I do is put them in parentheses, and then I'm gonna have my 1/6 2x minus 6, and then we've got the cube there, and then I've got the values of 3 and b that I'm gonna sub in. Okay, so I'm gonna sub in the values of my 3 and my b. Okay, so bear with me. So what we had was the parenthesis 1/6 2x minus 6 to the power 3, and we sub in 3 and b. Okay, and then we expect to get 36. That was the question. So we're gonna sub in our 3 and b first, then our 3. So we got 1/6, 2 loss of b is 2b minus 6, all cube. All of these we're gonna subtract our 1/6, 2 loss of 3 minus 6, remember all cube, and then we need to make sure it's 36. Okay, so we're gonna sort this out. You can grab a calculator to help you here. Okay, so with that we'll do nothing to it, we'll just copy it down. So we've got 1/6, and we've got bracket 2b minus 6 cube. Okay, take away. Now in this bracket, if we work it out in our calculator, we will get 0, and this gives us 36. Okay, so basically we've got 1/6 2b take away 6 cube equals 36 to work out. We have a fraction here, so the opposite is to multiply by 6, and that gives us 2b minus 6 all cube equals, well, I don't want to really work this out. It will be easy to just leave it like that. Of course, if you have a calculator, you can do that. 216, and then you cube root both sides, so that gives me 2b minus 6 equals just 6. I add 6 to both sides, 2b equals 12. Divide both sides by 2, and b is 6. So you notice we've just solved this question straight away, but with the help of our understanding of the reverse chain rule. Okay, now there's one more question which is technically not hard, but it looks very hard from the onset. However, I would like you to try and pause the video, have a go if you can do it, and if you can't do it, by all means look at the video, take some notes. Again, don't panic when you see questions, just be calm. The question says, given the integral from e squared to e to the power 8 of 1 over kx with respect to x is equal to 1/4, comma, find the value of k. We're going to work out the value of k. You can by all means pause the video and have a go at this question. If not, feel free to watch it and take notes as you go along. Okay, so first of all, we're going to integrate 1 over kx. This is one of our standards. By seeing 1 over k as a scalar, I can literally think of 1 over k outside, and then I'm integrating 1 over x. So I have 1 over k, and I'm integrating e squared e to the 8 1 over x with respect to x, and I want my answer to be 1/4. Okay, what that gives me is that if my scalar is there, 1 over x will give me the natural log of x. This natural log of x, I have it to the e squared and then e8, and I want to get 1/4. Remember, my job is to work out what k is. Okay, so of course I've got k in the denominator and I've got 4 in the denominator. I can see that if I multiply both sides by k and I multiply both sides by 4, I can have the k on its own. So I could have k equals 4 natural log of x. Remember, I'm here to sub in e squared and e to the 8. Okay, so I'll sub in e to the 8 first and then sub in e to the 2. So k will be 4 natural log of e to the 8, yeah, and then take away the natural log of e squared. Okay, I know that by the laws of logarithms I can divide. Okay, so that gives me k equals 4 natural log of e to the 6, because e to the 8 divide e to the 2 is e to the 6. Now per the laws of logarithms, remember natural log means log to base e. Okay, so I'm going to use the power law of logarithms. That means I'll have k equals 4 times 6 natural log of e. Now natural log of e, this is just 1. So I technically have 4 times 6, and therefore that means k is 24. 4 times 6 is 24, and that is straightforward, and that's very easy. Remember, when you see a question, don't panic. Just look at it. Is it a standard one, or is it a reverse of the chain rule? By reverse of the chain rule, what we are saying is, what was it that was differentiated to give me what you see? And if you can think of that, you can always pick it out. Remember, if it's got a power, you go to the higher power. Don't forget to share and subscribe. More skills of this are gonna come. The next skill of integration is gonna come, and we'll look at trig identities and go on to the trapezium rule and so on. Stay tuned and keep on watching Ninson's Math Solutions. Hey, I hope now you know how to integrate sine 2x plus 1 with respect to x. Don't forget, add your c for indefinite integrals. And of course, we know for definite integrals, we need to sub in our limits, our values. And remember to be able to solve the equation. Don't forget, continue to watch Ninson's Math Solutions. Subsequent videos are gonna come. I'm gonna teach us how to solve trig identities, integrating them, how to use the trapezium rule, and some other tricky and difficult integration questions, including differential integrations. Thank you for staying tuned and watching. Continue to follow Ninson's Math Solutions.